This problem and all other practice problems for Calc 2 here at Rutgers can be found in Sarai Studies. A link is in the description box below. Does the following series converge or diverge? So we're going to be using the LCT, so limit comparison test. So the rules for LCT is based on the limit as n approaches infinity of a of n over b of n, and that's going to be equal to a limit, or in Rutgers we call that rho, even though it's a p. And so we have three rules. I always start with the bottom two. So if rho is equal to 0, if rho is equal to infinity, and the series b of n converges, diverges, then the series a of n will converge, diverge. And so the first rule is a little different. This is when rho is not 0, so it's non-zero number, and the series b of n either converges or diverges, then the series a of n will do the exact same thing. So if we find that this converges, then we will know this converges if the limit, or rho, is a non-zero number. Recall that DCT is IBBCC, and LCT is IBBLC, so one letter difference. In DCT we're comparing, and LCT we're finding the limit. So the I stands for information, what we know plus what we need. So what we know is that a of n is always the given sequence, and what we need is b of n. We don't know what that is, which brings us to our second step, which is b for finding b of n. How do we do that? We take our given sequence, and we ask ourselves, at large n, so when n is really big, this becomes what? Well, as n approaches infinity, right, because that's what this means, what becomes insignificant? Well, adding a plus 1 to infinity and adding a plus 2 to infinity is not really going to do anything. So it's really insignificant. So the 1 and the 2 are going to go away. So I would say that at large n, this becomes the square root of n over n squared. And that is your b of n. And that brings us to our third step, which is b again, but this time b stands for behavior of the series b of n. We're trying to find how does the series b of n behave. Does it converge or diverge? So we have the series n is equal to 1 to infinity. I get that from here, of b of n. Does that converge or diverge? Well, that depends. The only tests that we use here are the p-test and the geometric test, and so the way to find which test you're going to use is to make sure that your b of n is completely simplified. So this really can be rewritten as the square root of n over the square root of n squared. This cancels out to be square root of n over just n. So this is our simplified b of n. But that's still not really a form that I recognize, so maybe I can simplify this even further, or rewrite it n to the 1/2 over n to the first power. So 1/2 minus 1, well, that's going to be 2. 1 minus 2, that's negative 1/2, meaning that we have 1 over n to the 1/2 at the bottom. Now that is a form that I can recognize, because here I recognize that this is in the form of 1 over n to the p, where p is equal to 1/2, so I know I can use the p-test. The way that I remember the p-test is the movie rating PG-13, so p greater than 1, and then converges always comes first, and then the opposite is going to be true. In this case, p is equal to 1/2. That's obviously less than 1, because you're taking 1 and dividing it, you're making it smaller. And so because p is less than 1, the series diverges. So already we have that the series b of n diverges. Remember, these always have to be the same. So already we have two options. Either the series a of n is going to diverge, or the series a of n is going to diverge, but they will diverge for different reasons. This will only happen if rho is not equal to 0, and this will only happen if rho is equal to infinity. So that brings us to the next step, which is L, find the limit, find rho. So here we're taking the limit as n approaches infinity of a of n over b of n. So a of n is this, but I'm not going to do the over b of n. Nobody does that. We just save time by just flipping b of n. In this case, we know that b of n is equivalent to n to the 1/2, so it's really easy to flip this. Literally just flip it, so it's n to the 1/2. So this goes at the top and this goes at the bottom. Flip and you get n to the 1/2. Now this here can be rewritten as the square root of n plus 1 over the square root of n squared plus 2. This here can be rewritten as just the square root of n, because it's easier to see things that way in this case. Because really what I'm going to do is distribute that square root of n. And remember that when you have roots, you can just join everything together in multiplication. So that becomes n times n plus 1. And then within that, you can distribute that n. So that's n squared plus n. And now you have a really nice, beautiful rational fraction, and you can divide every term in that fraction by the term with the highest power in the denominator, and so that's n squared. So this becomes 1, this becomes 1, this becomes 1 over n. So this becomes the square root of 1 plus 1 over n over square root of 1 plus 2 over n squared. Now if you plug in infinity, infinity squared is just still infinity. And so these go to 0 because remember, one whole divided into infinitely small pieces becomes infinitely smaller. So small, you can barely see it. It's 0. So you're left with the square root of 1 plus 0, square root of 1 plus 0, which is simply just square root of 1 over square root of 1, which is just 1 over 1, which is just 1. And so we have that rho is equal to 1. So if we go all the way over here, rho is a non-zero number. So we know that if this is true and this is true, then we can say that this is true, that the series A of n, our given original series in question, diverges. And that is the answer to our problem, which leads us to the last part, which is the conclusion, where we put everything in a nice, clear sentence. So I always start with since, and then I go in the order of my work, so blue and then green. So since the series B of n, you can write either this or this for B of n, it doesn't matter, they're the same thing, diverges by the p-test, where p is equal to 1/2, which is less than 1, and then the green part, this I literally just take the actual limit in the beginning, drag it down, say what it's equal to, say that it's not equal to 0, comma, the LCT, the limit comparison test, implies that the given series in question from n is equal to 1 to infinity of whatever this is diverges as well. So that's it for this problem. I'll see you in the next.